Hi everyone, thanks for joining in. We'll get started in another minute. We're just waiting for other folks to log in for the session, and we should be in a good position. Thank you for your patience. Awesome. Let's get started without any further ado. Good evening, everyone, and welcome to the 8th AAB session of ONDC Presents Build for Bharat. The initiative is supported by Startup India, sponsored by industry leaders such as Google Cloud, Protein, Antler, and Paytm, and also powered by Hack to Skill, My name is Shakti Singh. I'm a program manager at Hard to Skill, and I'll be your host today. So we'll walk through the problem statements that we are going to discuss during this whole AMA session. You guys have chosen those ones, and you've got the invite. You're here. We have the speakers with us. So in case you have any questions, feel free to post it in the chat sections. We might also have an open mic discussion at the end of the session while we, discuss on the problem statements, discuss the frequently asked questions, and therefore we'll open up mic for you guys to ask questions to the speakers as well. So now just let's now deep dive into the flow of today's session. We have our experts here, and today we will be addressing the frequently asked questions on the two crucial problem statements. One is using open source maps, and the other is optimal storage and retrieval in MNX, sparse metrics. We will be the first answering queries which we have received from you through the Google Forms that we have circulated in order to put your queries daily. You're working upon it. You might have queries coming in your head. And that's going to be the flow of the whole event. Not just that, we have our special speaker for the day with us, Hi Supriyo. Thanks for joining us today here. So Supriyo Ghosh, he is the chief architect at ONDC. He is the lead for the tech design of ONDC network and handles technical coordination with participant community. He has also worked on several population scale mission critical projects for the government, including Aadhaar, National ID, and social protection systems. He previously handled software development roles at Oracle Corporation in US. He is a graduate in computer science engineering from IIT Kharagpur. We are so delighted to have you today with us, Supriyo, here, and we look forward to your session. That was just a quick introduction about myself. Why don't you, introduce us and let us know what you actually look into at ONDC?
Thanks, Shakti, and good afternoon to everyone attending this call. Can we go to the next slide? So what I'll do is, as Shakti mentioned, I'll cover these two problem statements. I'll get into some details of these problem statements. Before that, I'll give you a little bit of understanding about ONDC so that you can understand, our purpose behind defining these problem statements. And then we'll take up the questions that you've submitted, and then we also will have other questions that you may want to raise through the chat window that also we'll address. So I don't know how many of you have heard of ONDC, but ONDC, it's so what we're trying to do at ONDC is create some kind of an open commerce network so that anybody that wants to sell, they can come on the network. Anybody that wants to buy, they can come and find anybody that wants to sell. And, our job is basically to match, supply and demand at scale. Now, there are two things that you must have heard about ONDC. What we've done. So if you look at digital commerce itself, digital commerce is a difficult problem. If it were not, we wouldn't have one or two players, surviving in digital commerce today. Now, considering that it's a difficult problem, what we've tried to do in ONDC is actually introduce two additional pieces into that whole puzzle. So we've actually separated out the supply side and the demand side. So in other words, it's not like a monolithic platform, but we've kind of separated out the supply side and demand side. You must have heard of things like unbundling. So we, ONDC, we have what we call as buyer apps. We have what we call as seller apps. Buyer apps are the ones that actually bring in the demand. Different types of buyers, they come through the buyer app. If they want to buy something, from any seller, they kind of initiate a search request through the network. There are sellers that are interested in kind of showcasing their catalogs. They respond, and then the buyer might decide, whom they want to proceed with, for kind of concluding a transaction. So there are buyer apps, there are seller apps, there are logistics providers, plus there'll be all other kinds of service providers that will come onto the network in future. Now, our challenge as ONDC is how do we make sure that digital commerce actually works, across this wide ecosystem of participants, across the ecosystem of buyer apps, seller apps. How do we maintain interoperability? In other words, any buyer app that comes onto ONDC, they will be able to talk to any seller app on ONDC. And similarly, anyone who wants to be online in digital commerce, if they come online, their catalogs and plus their order management kind of interface, that will be available to any buyer who comes in through any buyer app. So it's basically enabling interoperability at scale across a wide ecosystem of buyer apps and seller apps. That in a nutshell is ONDC, and I'll get into more detailed description of these problem statements and why these are important for ONDC. Now, I don't know how many of you have worked in digital commerce before, but in digital commerce, there is this concept of serviceability. In other words, I have a store. I say that I'll only so let's say I have a small restaurant. I say that okay, I'll only service my neighborhood. In other words, some specific region that I define. I say that I'll only service here. So if anybody that wants to buy from within this region, they can get in touch with me through ONDC. They can make a request. I'll be able to showcase my catalog to them. I'll be able to do a transaction with them. But if somebody is outside that region, then I won't be able to fulfill orders for them. Similarly, there could be a big brand who comes and says, okay, I have a warehouse, and using that warehouse, I'm going to service the city of Bangalore. Somebody else might come and say, I have warehouses in multiple places in the country, and using those warehouses, I'll be able to, fulfill orders pan-India. So there are different types of sellers that come in, each of whom define their own serviceability requirements. And what we try to do is we try to match, buyers that are meeting those serviceability requirements when they actually place an order. So that's the concept of serviceability. Now, one of the most, the two of the most common kind of artifacts that are used in serviceability, one is pin codes and second is what we call as polygons. So pin code is like the example that I gave of a big brand. They come and say, I service the city of Bangalore. The city of Bangalore is actually pin codes, from 56001 to 56100. Now there are a total of 30,000 pin codes. Similarly, another seller might come and define a region, which is like a polygon. Now, if you see this, there are on ONDC, we expect tens of millions of merchants. Now, assuming we have 10 million merchants, each merchant, they define a polygon, and no two merchants may or may not have the same kind of polygon. So what you effectively are looking at is, there are a certain number of regions, and we've taken the example of a pin code. There are about 30,000 pin codes. There are about 10 million merchants. Now, when somebody is trying to send, now on ONDC, I talked about the buyer app and the seller app. So what happens is, I as a seller, I send my serviceability requirement, which is I define a polygon, and I say that, this is my serviceability region. Somebody else defines a serviceability region using pin code. Somebody else defines a serviceability region for pan India, which is basically, again, nothing more than a polygon or, a set of pin codes. But assuming we have, so there are these different types of sellers who send the serviceability requirements. And what the buyer apps do is that they collect, along with the catalogs, they also have the serviceability requirements from different sellers, which they have. And they basically, so when all this information comes, they have to figure out a way to store this efficiently. And then when some buyer is trying to look for something, they have a very efficient way of kind of retrieving information from that storage, of the serviceability data that has been provided. So to continue with this example, there are 30,000 pin codes in the country. There are about 100 million merchants. And, so if all 100 million merchants send their serviceability definition using pin codes, for a typical buyer app, that wants to service, that wants to give access to buyers, across the country, they would effectively need to store, the serviceability. So they would effectively need to store data which is of this form, 10 million into 30,000. So in other words, there are 10 million merchants, 30,000 pin codes. Effectively, it becomes kind of a 10M into 30K matrix. And it will be sparse. It will be kind of a sparse matrix. But that is the universal set. And within that universal set, they'll have to figure out they'll have to figure, first of all, they'll have to figure out an efficient way to store it, and second is they have to figure out how to actually retrieve it. Now, there was one thing that we mentioned in the problem statement is that the definition and verification of pin code based serviceability is separated, which means that the serviceability definition is by the seller side, and the verification, trying to match a buyer based on their current coordinates with the actual serviceability definitions that have been provided. That's on the seller side, and on the buyer side. So the definition is from the seller side, but the verification is on the buyer side. So this is kind of separated. So the problem statement here is that we provide an efficient way for the buyer side apps to actually store this kind of data. So like a sparse matrix of 10 million into 30,000. And then when a buyer, and they'll have multiple buyers who are trying to access the system, access their app at the same time, so that in near real time they are able to kind of verify based on a buyer coordinates which are the sellers that actually will be able to fulfill their order, and making sure that those are the sellers that they showcase to the buyer. So this is the optimal storage and retrieval in an M by N sparse matrix. Can we go to the next one? Now, the open source maps. So what happens is that maps is again a very key component of any digital commerce system. I'll give you a few examples. One is, if I have to define so I talked about serviceability definition in the previous for the previous problem statement. Now something like this. Let's say if I want to define a polygon for a certain region in Bangalore. Now there are maps which provide all this information. You enter some kind of input, whether it's an administrative area like a specific set of pin codes, a city name, or maybe some other things, and it actually generates a polygon for you in any format that you want to. Similarly, there are a lot of kind of hyperlocal apps, whether they actually serve grocery or food. They actually show a tracking. Like in real time, you can actually track the rider who is coming to deliver your order. Second is that when a buyer places an order with a particular seller, seller has to look for logistics. So here I talked about unbundling. Even logistics is available as a separate service. So when a request comes to the seller looks up a logistics provider. Logistics. So what the logistics provider does is, based on the start location and location, they kind of compute the motorable distance, and they come up with a quote. So this computation of motorable distance, this is again another feature for which maps are required. So there are quite a few of these kinds of features for which a map is required. But there are mapping technologies available today. But whatever technologies are available today, those are kind of licensed technologies, and those are very expensive. Now, one of the goals of ONDC is to democratize digital commerce. Now, if you look at digital commerce today, in the platform world, what happens is, the participants in digital commerce are either the large brands or the logistics providers, who have kind of a pan-India presence. On ONDC, we expect, large logistics providers. We expect even the small logistics providers like, what we call as Mohalla logistics provider, who might actually deliver to a few regions. All of them can participate on ONDC. Now, but for them, mapping technology is going to be a constraint. So the open source maps, it is something that that can be made. So the reason that we're talking about an open source map is basically to make it available for them, so that they can actually use this technology and come on to ONDC. So for those who cannot afford the licensed mapping technology, they can use this and come on board ONDC. Now, if you look at the mapping technology, this is so some of the functionalities that I mentioned, like creating polygons, generating motorable paths, computing the motorable distance. There's also something about reverse geocoding. Reverse geocoding is, there is an address. There is an address. From the address, I need to find out what is the GPS coordinate. That is very frequently used, computing distances and mapping points with support for various representations. So now for the open source maps, there is mapping technology. There is also data behind those maps. And I think a lot of this data is available in open source. Even some of the open source maps which are out there, we have a list of some of those maps which are out there. But but points on a map, it can be represented in various ways. GPS coordinates are quite common. There is also Google S2 cells. There is Uber H3 cells. Plus, I'm sure there are quite a few others. So this is the definition of the problem statements itself. Can we start with the questions, Shakti?
Sure, Supriyo. Just give me a moment. Okay, we'll cover up the questions firstly for open source maps, like we recently did that, right? Discuss. So
yes,
that's okay, right?
Yeah.
All right. So the first question for me would be, as we know, the rule guideline says that deploying your project's POC MVPs on Google Cloud is mandatory. Me and my team are building a so that's related to Google Cloud mostly. So maybe I can address that. So first and foremost, the Google Cloud credits would be for the nominated teams and the approved ideas solutions. It will not be distributed randomly. You, anyways, when you sign up to Google Cloud, you get free credits. You need to avail those in order to build up your MVPs and POCs at the moment initially. And then you go ahead with that. So on the approval side, you'll only get onto those questions there. All right, so the other question is, what logistics are to be covered in open source maps problem? Is it in context of buyers, sellers? If I'm a small seller selling products from different companies at my shop. Supriyo?
Yeah, so logistics means if you look at the so I think this problem is related to open source maps. Okay, so open source maps, what we need is so there is a set of points, and there is data for those points, and there is a mapping technology which kind of actually plots those points on the map. Now logistics as such, so we've not said that you cover logistics in any form, but what needs to be done is you need to figure out that how do we take existing open source mapping technology which is already available and map it with a specific set of data points which are available, and then make some of these functionality that is actually used through open source maps available, kind of workable on that kind of solution. So we didn't ask specifically for logistics. Some of the things that you would try to do in an open source map is, let's say I give a start and an end point, generate a multiple path between those 2 points. If I give an address, try to reverse geocode the address and come up with the GPS coordinates. Then if there are 2 points, along with generating a motorable path, you also compute the motorable distance and probably the time that it will take to cover that motorable distance. So these kinds of things are what we expect you to cover, because these are like the fundamental problems that a logistics provider will actually solve using the open source map. If you can think of other such problems, my suggestion to you would be look at Google Maps, look at Mapples, the Map My India, see what kind of mapping functionality they provide, and try to kind of fit that with what is required in digital commerce, and try to simulate as many of them as you can.
Okay, we have a few questions in the chat as well. I'll pick up one. It's related to open source map itself. So how are the solutions going to be judged? Like, what is the judging criteria for open source maps? So here's a follow-up question there is, will we be leaning more towards the best algorithm implementation of the features mentioned, or more on the number of features implemented? Features like polygon, motorable route, reverse geocoding, or more. So if you're answering that,
yeah. So the judging criteria, I would think, would be the kind of enabling those features on the open source map. Algorithmic implementation of the features mentioned, or more on the number of features. So I would say it's a combination of both. It's like the number of features that you enable, plus how exactly you implement it. Third would probably be whether how cleanly it is abstracted, whether it can be how easy is it to integrate with any participant, and and along with that, I think some of these things like the footprint and all that would also be considered.
Awesome. I hope that is answered to you, Mahesh.
Mahesh.
Mahesh's question is somewhere related to open source routing machine. Provide many of these such out of the box ideas like routing, geocoding. What is the expected beyond what provided? So Mahesh, if you can elaborate on that question more. We'll open up the mics, Mahesh, at the later stage. So at the moment, if you can just put up your questions broadly again, we can take it off from there.
Yes, Mahesh.
Okay.
Mahesh, you're there?
Mahesh, if you're there with us, if you can help us understand more on that question.
So what I was asking was that, yes, Supriyo. So like OSRM, right, has a ability to self-host and run. And out of the box, when you host that OSRM service, it gives you routing, it gives you geocoding, it gives you reverse geocoding as well. Now, you can always keep updating with the latest data that's community sourced. But my question then is that, as part of this solutioning, out of this hackathon, if some of these are directly resolved or provided by such software, what is expected beyond what's directly being provided by them?
Yeah, so Mahesh, I would say it's two things. One is OSRM is kind of a backend engine integrating OSRM with the mapping technology like OpenStreetMap, and there are a few others which are out there. Second is some of these things like I don't know if OSRM has definition of all these administrative areas term, which is actually a concept which is used in a lot of these commercial maps. So they define administrative areas, which will actually help in creating polygons, for example. So one is creating custom polygons. Second is creating custom polygons using administrative areas. For doing that, you will actually need to come up with some kind of definition for administrative areas. These are the things that I'm thinking of right now.
Okay, got it.
All right, thanks, Mahesh. Thanks, Supriyo, for addressing that. So I guess we are getting more questions into the eminent Sparse metrics question. So we'll switch on to that one first. And in case if you guys have any more questions related to open source maps, please feel free to post it in the chat so that we can take it off from there. Okay, I have a few questions from my side, Supriyo, before we head towards the chat.
Sure.
Okay. Can you please provide us other important constraints like how data will be stored or the structure of the data for us to make look up faster? And even if it is a sparse matrix, meaning how has more non-zeros, we will require the conversion the matrix or to optimal cost, CSR, doc as well, right?
Okay, so I'm not sure what some of these terms mean, but see, the whole sparse matrix problem is related to efficient storage and retrieval. Now, whether data needs to be stored in sorted form, unsorted form, that I think you'll figure out, faster than us. But the problem statement is pretty clear, which is that there is data, and for lack of a better term, we call it a sparse matrix. So there is data in this particular format. You'll have to figure out what is the most efficient way of storing it and what is the most efficient way of retrieving data from there. And there are a lot of tools that are available to actually generate, the test data for this. You could probably generate random test data and, kind of populate the matrix. But the main thing is, efficient storage and efficient retrieval.
Great, thanks. I have a follow-up question to that now that we are talking about data. If possible, will ONDC provide some data on which we should work upon?
No, I mentioned that, you can actually generate your own data. And there are utilities available, on the web using which you can easily generate this data and use it.
All right, great. I have a few more questions just to fill up the gaps now. So somebody has asked that the challenge name is optimal storage and retrieval of sparse metrics. Does that mean that we have to take the raw data, however you'll give us B in M into N, CSV, etc., then store it in an optimal data structure for faster retrieval? If yes, do we get time to store data in our own data structures?
So again, the raw data is something that you generate. Now you generate the data, you store it in a data structure, and then you retrieve from the data structure in the most efficient way possible. Try to, so this is again your problem statement. So we are not going to give you the data. You can easily generate your own data, and storing it in your own format, definitely. But you should also provide a way to, for it to kind of accept data feeds. So the input and output, those have to be standardized, but the internal mechanics of how exactly data is stored and retrieved, that is up to you.
For sure, thank you. Also, somebody has asked, related to the problem statement, what does the word separated mean in the problem statement? For the system to be concurrent, we need a relation database to store the pin codes and sellers as sparse matrices. Can we implement this way?
See, relational database for storing pin codes, I think that would be kind of an overkill. Now, any data which is more in master data form, you really need a relational database to store it. You can think about it, because relational data solves a problem, something called referential integrity, which is not really a factor for the pin codes. Now the separated part, when we say separated, it's again, so in the traditional e-commerce world, what happens is, having the pin codes or other definition and verification of serviceability, it happens in the same place. Here it happens in two different places. So in other words, one side defines, one side kind of defines the information, the other side it kind of aggregates information from multiple aggregates multiple such definitions, and then provides a way to efficiently filter information from there. So it should be, so the reason we mentioned about efficient storage and retrieval is that it should be easy to kind of communicate this information, serialize this in a particular format, and transfer it from one side to the other side. So separation is basically meaning that the definition and verification, those are done by two separate parties.
Great, thank you for addressing that. In case you guys have any questions, people present on the meeting, you have any questions, please feel free to raise your hands. We have sufficient time to address all the queries. You can ask questions straightly to Supriyo, and maybe we can take it up from there. So why don't we start? And also requesting, before opening up the mics for everybody, let's stick towards the questions that are focused on the problem statements and solutioning piece, and not proposing your idea or maybe getting very justifications on your idea. That is not something that we will go ahead with. Just focus majorly on your problem statement, and let's ask questions to Supriyo. Supriyo, we're opening up mics. First would be sustainable venture. If you're there with us, see any sustainable venture. Can you hear us? Okay, if not, let's just go ahead with Karan Agarwal.
Yes, sir. Can you hear me?
Yes, we can hear you. Please go ahead, Karan.
So my question is, we are now supposed to submit our idea for this, right? So since we are not sure about what kind, in what format, like the data will be given to us. So when we are presenting our blueprint, shall we mention in slashes, like if the data comes in this form, we are going to go ahead and store it like this. If the data comes, we'll again manipulate it and then store it like this. How are we going to go ahead? What is expected in the terms of presenting our idea?
See, again, there is a problem statement which has been defined. And now, if you want, so you can make your own assumptions wherever you feel that making an assumption is required as long as it's not defined in the problem statement. But please call it out. So one point that you mentioned about data, which is that if data comes in a particular format, then I store it like this. In a different format, I store it. I kind of convert it and store it. Or you can define a standard interface, for also feeding the data. That is also possible. So you can make assumptions, but please call it out. Please make sure that it is transparent.
All right, then that would be great. Thank you.
Thanks, Karan. Thanks, Supriyo, for addressing that. Jia, if you're there with us.
Yes. Hello. Am I audible?
Yes.
So my question is related to open source maps. So it is that say I'm on a application and I'm ordering a cab there. So what will that call look on the network beneath there? Like, will that call go to the that request would go to all the drivers listed on any platform, or will that be going to just the drivers associated to that particular application?
See, on ONDC, what we do is, so any search request that the buyer initiates, we actually fan it out. Fan out means we broadcast it to everybody that had expressed an interest in that. Expressing an interest means today it's at a fairly coarse-grained level. It's like we have different categories. You have grocery, you have food, you have. I'll talk specifically about retail. We have grocery, we have food, we have fashion, we have electronics. So I register myself as a fashion seller. So if somebody is searching for, some fashion items, whether they're searching for summer wear or winter wear or whatever it is, then I get the request. But if somebody is searching for a burger, I don't get it. So anybody that has registered their app on ONDC has registered themselves as a participant on ONDC, and they have expressed their interest in a particular area, they'll get a request whenever somebody is searching for that.
Okay, so when I'm searching for that, so I'm saying as in the perspective of using open source maps there. So because the logistic partners, okay, so you're saying that request would go to the every logistic partners registered over there. Is that?
Yes. So the request will go to also again logistics partners. They have so some of them operate pan India, some of them operate in specific cities. So it depends upon the request coming in. Is that for a specific city? Is that for pan India? So based on how they have registered, the request will be found out.
Okay,
but again, the
thank
mapping. So the mapping technology, what happens is, if you see, so there's a request that comes to the logistics providers, and if they have to send a tracking link or whatever, right? The tracking link comes later. It's not immediately at the time of doing a search. But a lot of these computations that are required, those can happen in between. So typically on ONDC, what happens is somebody makes a search, then there is there's a process of actually creating an order, placing an order, and then the post-order, formalities like, okay, monitoring the order, making sure that it is delivered and all that. So whether it is for grocery or whether it's for mobility, it works the same way.
Okay. Okay, thank you.
Thanks, Jia. Thanks, Supriyo. Karthik, if you're there with us.
Am I audible?
Yes, you are.
Okay. So my question is based on the optimal storage problem statement. So here are we, sir? So are we talking about optimal storage in a database, or are we talking about optimal storage and representation within computer memory, sir? Like in-memory representation, like within a data structure.
See if I were to do it, I would probably say that you need a persistent storage, and you also need if you have, and so first is you need persistent storage, right? Because all this information that comes, you need to store it somewhere. Second is at the time of retrieval. Obviously, if you have to do retrieval in near real time, it has to be done from memory. Now the question is, do you load the entire sparse matrix into memory? If so, how do you make sure that it doesn't consume all your memory, and then do a retrieval? So I would think it has to be done in both places, right? Memory at real time, whenever whenever you're trying to retrieve information, it has to be stored maybe in shared memory, so that multiple concurrent users can be served at the same time.
Yes. Sir, also one more question regarding the same statement, sir. So for the judging criteria, so it will be judged based on the efficiency of based on just the time it generally takes to efficiently store and retrieve data, right? Will be judged based on like the use case in let's just say like more than the algorithm, I focused more on like the services on top of it, like an interface, an application, like a mobile application on top of it. Will it be judged like based on that, or will it be judged solely based on the algorithm, sir?
So see, the optimal storage and retrieval, right? When we talk about optimal storage and retrieval, optimal? So if you talk about optimal storage, it means that it should be efficient. In other words, it uses the least amount of storage, both persistent and in memory.
Yes,
and even the retrieval, it has to happen in real time. Plus, the abstraction has to be very clean, so that anybody that wants to use it, they can easily integrate. And when you talk about clean abstraction, again, there are a few other things that, so integration, the ease of integration, a few things come in. One is obviously the clean abstraction. Second is the footprint. And third is, the data exchange interface. So I would suggest you look at these things very carefully.
yes, sir. Thank you, sir.
Thanks for asking that question, Karthik. Aniket, if you're there with us.
Yeah. Hey, Supriyo.
Hi.
Yeah, I just wanted to inquire how the solution will be evaluated. Like, is it for the particular use case of pin code serviceability, or the architecture and the data structure used to store and retrieve the sparse metrics would be weighted much?
So I think I answered that problem just now. I answered a similar question just now. But see, if you take a step back, right? Why are we defining these problem statements? Because these are, I would say these are like plumbing level issues that have to be resolved for ONDC to scale up. Now, if these are plumbing level issues and you come up with a solution for, let's say, either of these problem statements, then it should be very easy for somebody. So first of all, it should obviously solve the problem statement, in the way it has been defined. Second is, it should be very easy for somebody to actually take your solution and integrate. So in other words, you should look at both things. One is functionality, functional completeness, and second is obviously the ease of integration.
Yeah, okay. Also a follow-up question. Are there some benchmark that would be used to justify the speed or the efficiency of the data structures?
I am not aware of anything right now. If anybody on the call is aware of these things, they can please, respond to this. But I'm sure you can find out a few things about this on the web itself. And if you want to provide a benchmark, that's even better. If you benchmark your own, solution against similar solutions that are out there.
Okay. Thanks, Supriyo.
Sure.
Thanks, Aniket, for pulling that up. Saptadeep, sir.
Good afternoon, sir. Actually, my question is that, as you have said, that the solution should be highly scalable, and for the pin code retrieval and storage system to be concurrent with all the buyer and seller apps, and for it to be very much scalable, we need to implement it in a database. But as in the problem statement, there has been no mention of using databases. It is just about implementing the data structure. So I was asking if we can implement a database to make the solution more scalable.
See, the database is also a data structure. Now, whether you need a database or not, that you are the best judge. But again, when you talk about scalability, so just wanted to, take a step back and tell you a little bit more about ONDC. So on ONDC, what happens is there is like a network of participants. So it's not like, that it has to be scalable across all buyer and seller apps. No, it's like, if you look at the sparse matrix, it's like there are, let's say, 1 million sellers. Each of them, define their serviceability. Now there'll be fewer buyer apps. Now what happens is the buyer apps, they collect data from all these sellers, and then they they store it and then they retrieve information in such a way so that they can provide the digital commerce kind of interface to their own buyers, and this will be done by multiple buyer apps which are there. I mean, there could be, if you look at buyer apps, PhonePe is a buyer app, Paytm is a buyer app, Magic Pen is a buyer app. So these are all buyer apps. There are multiple of them. So it's not like there is one centralized solution which has to be scalable across everybody. Okay, that's point one. Second point is, if you see this, what happens is one side it kind of comes up with a serviceability definition and then serializes it in a form in an efficient way so that it is transferred to all these different buyer apps. And then buyer apps, what they do is they aggregate this information which comes from all the different seller apps, and then they store it in their own data structure. Can it be a database? Definitely. Is that the only solution? I don't think so.
Okay, thank you.
Sure.
Sure. Thanks, Saptadeep. Nancy.
Hey, I wanted to ask about the Sparse matrix. In what ways will the location input be considered, like pin codes, city names, and the polygon you were talking about? Can you tell us something about that?
See, the location inputs, a very simple example is polygon. If you take polygons, now we at ONDC, we at least on the the open on the network side, we try to follow open standards. So there is GeoJSON. You can check GeoJSON standard. Now GeoJSON, it is actually a set of GPS coordinates. That is one example. You can have GPS coordinates, which kind of defines a polygon. It could be a set of pin codes. Pin code is the standard definition in India. So location. So typically, if you look at any maps, they take, they consider location as either a kind of either in lower level form like GPS coordinates, or in a slightly higher level form, which is like the administrative areas. It could be a pin code, it could be a district, it could be a parliamentary constituency, assembly constituency. But finally, everything maps, to some kind of a polygon only. Does that answer your question?
Yes, thank you.
Thanks. Game Enterprises, do you have a question for us?
Hello, sir. I would like to know whether we should presume that if our solution is successful, is to be adopted and executed behind inside the ONDC architecture, or we have to develop the solution to be executed by ourselves as an independent entity, specifically for the M/N matrix.
Okay. See, ONDC, if you look at it, what we do as ONDC, we are a facilitator. So we have, we actually maintain what we call as a registry, which is a list of all the network participants. Beyond that, we just facilitate, the transactions that happen between different participants. So if you come up with a solution and that is something, so there'll be an evaluation which will happen. And if your solution turns out to be the best and you come up with some really innovative ideas, we will help you, find buyers for your solution. You can actually engage with them directly and, have them use your solution based on mutually acceptable commercial terms between you and them, not ONDC.
Okay. Because I'm asking with perspective, because some problem statements need to be executed between the API calls, the search APIs or whatever, the registry, and
No. See again. If you look at these problem statements, these are kind of autonomous problem statements. These are like self-contained problem statements. Okay, you don't link this to the functioning of the ONDC network itself. These are all independent problem statements. That's why we talk about clean abstraction, with the data exchange interface. Your solution, as long as it works, in a self-contained mode, it can be easily integrated into any other participant's app.
Okay, then it suggests that we should prefer for the autonomous or independent execution as long as possible.
It has to work in a kind of it has to work in an autonomous mode. Absolutely.
Okay, thank you. Because as a developer, it was a dilemma whether we should uh, give the
No, no, see,
solution.
digital commerce. See again, digital commerce. If you see, there are lots of other things. Okay, these are some plumbing level features which have to be enabled, and the easiest way to do it is if this functionality is available in autonomous form from someone, which can be easily pluggable, into the existing apps from participants.
Okay, thank you, sir.
Sure, thanks. Aditya, do you have a question for us?
Yeah, hello, sir. So I just wanted to ask, like, do we need to like take care of how later on the merchant data, like catalog data, is going to be stored? Like, do we need to give it any thought, or we solely focus on merchant and their pin codes?
No, you need not worry about again. So the problem. So we mentioned that the problem statement should be extensible. Now, if you come up with a way that you come up with a really efficient data structure, can that be used to store catalogs? It could be, but catalog is a lot more complicated than this particular problem statement as of now. But yeah,
Okay, so-
extensibility is a part of this.
Okay, so and one more question I had. So, does optimal only mean fastest retrieval or combination of other factors like scalability, speed, like architecture in overall?
See, optimal storage means obviously, the optimal storage. So there is requirement for persistent storage. There is also requirement for transient, in-memory kind of storage. Obviously, optimal means that the footprint should be low. Without a low footprint, it will be very easy, very difficult for anyone else to integrate, their app with your solution. Plus, wherever other requirements are there, we've called it out. So, things like efficient retrieval. Efficient retrieval obviously means, it has to be fast.
Okay, thank you, sir.
I mean, I hope that explains it, right?
Yes, sir.
Sure, I guess we have Aditya Dahalwal. Aditya? We'll take up two more questions from now and
I have a question about open source maps. So how output will be you want the output like pin codes, we will generate polygons of pin codes like that. Hello?
Sorry, the output of what? The open source map.
Yes, sir.
See, the open source map, there are, so again, there's a list of features, right? So my suggestion to you would be, now, for each of these features, there could be different sets of outputs. So for example, creating a motorable path between 2 points. Right, motorable path between 2 points is obviously a set of GPS coordinates in a specific sequence. It's like how do you create a path? It's like that, right?
Yes.
Computing motorable distance, between 2 points. Obviously, you define a unit and you define a measure for that. Something like reverse geocoding. Reverse geocoding is what? Reverse geocoding is you give an address, you come up with a GPS coordinate. So in other words, there's no standard set of input output, but for different sets of features, you could have different sets of input and output. So my suggestion to you is, if you're doing open source map, spend some time seeing what the commercial maps actually provide, and we've actually explained some of the features that we look forward to in this problem statement. But if you think something else also is value add, please feel free to add that. But please, if you're trying to work on this, my suggestion would be to look at how maps actually work today. There is enough mapping technology available. Figure it out, and then come up with a list of features that you want to enable, which would include some of the ones that we mentioned also.
Yes, sir. Thank you.
Thanks, Aditya. Karan, do you have a question?
Yes, so one last question I had was, if we are providing some cloud-enabled solution, so what cloud service provider solutions we can give? Basically, what ONDC makes use of.
So to take it up initially for you is, so if you're putting up your projects or MVPs onto cloud services, so make sure you do it on GCP. And therefore, your second question can be addressed by Supriyo. I have no idea, Supriyo, if you want.
If you come up with a cloud-enabled solution, as long as any other, and as we said, that these are plumbing issues in ONDC, and it should be easy for anyone to integrate with your solution, in an autonomous form. Now, you can deploy it in a cloud and someone else can integrate with it, that's fine. It's not for ONDC, by the way, it's for the ONDC ecosystem.
Okay. No, my actual question is, just say I want to use some cloud just for some storage and I want to give an API call to it. So for now, I can go ahead with Google Cloud Platform. But if the idea gets shortlisted later, do I get to still work on Google Cloud Platform or some other cloud providers also I need to look at?
I think when you commercialize it, that should be open. And Shakti can correct me if wrong, but I think you'll get a choice when you decide to commercialize it.
Yes, when you decide to commercialize your solution, then that's completely your call based on your experiences and the services that you want to take up. But for the current scenario, for the current initiative, while you're building up the MVP, the prototype itself, it should be on GCP.
All right. Thank you so much.
Yeah, thank you so much. Arden, a quick question maybe. You'll be the last one.
Yeah, good evening. I only want to ask Supriya to reiterate the very first thing that Mahesh said about that. What do we expect? Because there is already a lot of out-of-box products already present for OpenStreetMaps. So, and Supriya was talking something about administrative areas. So if he can just reiterate that one point once again, then that would be good.
See, the Mahesh mentioned about OSRM.
Yes.
This problem statement is, so OSRM is like a backend engine. You need to integrate OSRM with the actual mapping technology that are open. There's OpenStreetMaps, and I'm sure there are a few others as well. Now, so OSRM provides some of this information, like finding out the motorable distance between 2 points, maybe computing a motorable, reverse geocoding and all that. But something like drawing a polygon, which if you go to geojson.io, you can actually find out what that means. So you can actually draw a polygon between 2 points, then export the data in an open format like GeoJSON. Now, one is that you can actually manually draw a polygon. Second is that you give an input like administrative area. Administrative area is, most of these mapping technologies, they have administrative areas, whether it's a city is an administrative area, a district is an administrative area, a country could be an administrative area. So what happens is, instead of you sitting and manually drawing a polygon for each one of these, underneath these administrative areas, they already have mapping, from a particular city to kind of a set of GPS coordinates using which they can actually draw the polygons. So in other words, these are like higher level abstractions that help you create these kinds of polygons in a much faster and in a more efficient way. So some of these things are there in OSRM, whatever is possible through a kind of headless kind of backend interface, but there are quite a few other things which are not there as well. So my suggestion to you is, if you are actually doing the open source maps problem, spend some time looking at the existing open source mapping technology, the commercial one specifically, see the kinds of features that they have, and then try to enable those using your solution.
Sure, if that sums up the question, sorry. So we don't have any furthermore. So I guess we've answered most of the questions in the chat as well. So there's one question that is seeking my attention is from Pritesh. So he says, we are a startup working in fashion. We are applying for seller onboarding and inventory management. That's a different problem statement altogether, Pritesh. Please let me know, are you looking for only in grocery niche, or are you accepting from apparel sector as well? So we're doing that, so Supriyo, right? If you can give me a heads up. All right. So you can write back to us on our respective emails, which is there on the ONDC website. We can take up more questions from there. We will circulate an email to you guys if in case you have another set of questions that you want them to get addressed. We'll figure out another AMA session that can be elongated for like 2 hours, and then we can address all of your questions all together from there onwards. So that's pretty much about it for today's session altogether. With this, we have reached the end of the AMA sessions. If you all have that you receive another AMA session, we will share a Google form and an email as already conveyed to you. Now, I would like to, sincerely thank our speaker for the day, Supriyo. Thank you so much for having and being here throughout and addressing those questions and helping us understand more of the problem statements. And thank you so much, everyone, for joining us today and being an absolutely phenomenal audience and participants. We look forward to your exciting and innovative solutions coming forward before the submissions end. So just a reminder, the submissions closes on 10th of February. So make sure you make the right submissions before that. But thank you so much, Supriyo. If you want to take up the stage for last few words, over to you, else we are good to go.
Thanks everyone for taking the time and attending these sessions. We look forward to your submissions, and I'm sure you'll come up with something really innovative that we can actually use to solve some of the plumbing issues of ONDC and make it scale up faster. Thanks again.
Thank you so much, Supriyo. Thank you so much, everyone, for joining us today. And cheers. Have a great evening. Have a great weekend coming forward. Thank you.
Thank you, Supriyo. Thank you, Shakti.
Thank you, Kuldeep. Yeah.